Okay, so last time we were talking about regular expressions. We made it through basic regular expressions, and one section made it all the way through the extendeds, and the other section was just short of the repetition, but it wasn't too complicated. It just repeats the pattern. But keep in mind, there was an operator for, or there was a way to express a maximum number of something, but the issue with that is if we're always matching substrings. So if you don't specify what's on the left and the right of the thing you're looking for a maximum of, you won't get the maximum as in a limit. It will just guarantee that that number is contained within your pattern. So if you really want a maximum, you have to restrict what's on the left and the right of the thing that you're looking at. And the candy examples in the slides did that. So I think it's pretty well laid out in the slides. So we've been learning these regular expressions, and to demonstrate them, I've had to use this tool grep. Grep is a tool for searching through text, or more particularly, it's for filtering text, so it's a filter. So it'll read from standard in and write to standard out. You can also make it read from files. So grep's default behavior is to match substrings in lines. We can change that. And its default way of displaying the output is to display the matching lines, and you can change that as well. And then it has some defaults around if you give it multiple files, it'll show you the file names, but if you only give it one file, it won't. Of course, you can change various options to change that behavior. So it's a regular filter command line pattern. We've got grep, then we've got some options, then the first mandatory argument is the pattern. And then optionally, you can give it file names. So if you don't give it file names, it acts like a filter and it reads from standard in. So an example here, we're taking the man of grep, so the manual page. So if I was to run that interactively, I'll type man grep, and I've got the man page for grep, and I can inspect it. But if you run man as part of a pipeline, I'll pipe it through cat, then it just outputs the entire manual. Well, if grep is a filter, I can use grep to search this manual. So let's do man grep, and then let's search for an option. Let's see if it has a -o option. So I'll do grep, and let's not do -o yet. Let's just search for the word file, or actually the substring file. So it outputs the man page, and then grep only allows the lines that contain the substring file to proceed or to go through. That's a little confusing because we've lost all context. So I'm going to give it another option, -n, which will number all of the lines. So it's a little too wide for my screen now, but I can see, where's the break? So right there between 225 and 228, it dropped 6 and 7 because they didn't contain the word file, or the substring file. Okay. What was I looking for here? Okay, so I used another option, H. I believe that displays file names, or maybe it suppresses them. I don't remember. But I was looking for the substring file name in this example. Okay, so we've already talked about regular expressions. I don't think we need that slide very much, but it does say that regular expressions are interpreted by the command, not by the shell. But it shares some meta characters with the shell. So the star and the question mark and the square brackets, those are all meta characters that the shell interprets. Maybe even the round and the curly braces if you have it in a certain position on the command line. So if we don't want the shell to try to glob these patterns, we have to quote them. So we've been dealing with that already when we had the find tool and we wanted to pass the find tool a glob. We wanted find to get the glob, not the shell, so we had to quote the glob that we gave to find. So it's the same thing here. We have to quote the regular expression so that the glob doesn't try to treat it as a glob. Or sorry, the shell doesn't try to treat it as a glob. Okay, so here's a little example of not quoting. So I've got this grep, and if I'm looking for the string Gordon Lightfoot, and then I say I'm looking in this file, employee 1 list, grep is not going to handle that very well because grep takes the first argument that is not an option to be the pattern. So it'll say, okay, the pattern is Gordon, and then it'll try to open a file called Lightfoot, and it'll try to open a file called emp1.list. And then it'll give us an error because there is no such file Lightfoot. So if we actually wanted to search for the substring Gordon space Lightfoot, we would need to put it in quotes so that the shell doesn't take this input here, the Gordon Lightfoot part, see that, oh, it's got a word separator in it right there, and then treat it as two separate arguments. So the way we always solve that is to quote it. So if I put it in single quotes, or double quotes would work in this case because there's no other meta characters, then grep will receive Gordon Lightfoot as the first argument. And then it'll also see it has another argument, so it will go and try to open that file and search it. So in this example, it found it on this particular line. The same for all the other meta characters that the shell might interpret. We need to quote it so that the shell is not going to interpret those meta characters. So when grep runs, it's a regular command, which means it has an exit status when it finishes. So grep has 3 exit statuses. If grep doesn't find, okay, let me back up. Grep is a filter, and it only allows the lines that match its filter criteria to proceed. So that means if there are no matching lines, its output will actually be nothing. So we can show that. Let me get back to this one. What's this one? Don't need that one. Okay, so what do we've got? What have we got? I don't have a file that I can use, so I'll have to touch one. Touch foo. Okay, I'm just gonna put some garbage text in here. And some more. And some more. All right, 3 lines of garbage text. Save it. And then I'll cat foo. Okay, I don't know what's going on, so I'm going to Control C. We'll cat foo into a grep, and let's look for the substring bar. And bar is not in there. Okay, but you'll notice that grep's exit status was a 1. So grep will exit with status. Let's show it when it actually finds something first. So if I run grep with just an A, it allowed 3 lines to proceed through the filter because those 3 lines contained an A. And when I asked it for bar, it didn't find anything with bar. So when it finds something, grep's exit status is 0. So you see there's no error indicator there. And if I was to echo $? Then I can see its exit status was 0. Right, but when I run it looking for bar and it doesn't find anything, its exit status was 1. So exit status of grep is 0 when it finds something, or rather when it allows there to be output, and the exit status when it doesn't find anything is a 1. You can also get an exit status 2 if there's some kind of other error. So you either give it a bad pattern, or I don't know what it does when it can't find the file. So let's give it a bad file name first. Okay. Exit status 2. All right, so when there's some other kind of error, it gives an exit status 2. So we get a 0 when it was successful, a 1 when it doesn't find anything, and any kind of other error, it gives a 2. Right, the other kind of error that grep could give you, besides it can't open the file, would be if you give it a bad pattern. So I'm going to quote it so that it knows that this is the pattern, or the shell doesn't mess with it, because I'm going to give it some meta characters. Let's say that I'm looking for open square bracket. All right, so grep says that's an invalid regular expression because open square bracket's a meta character and it has to be matched with a closing square bracket. Okay. Right, where are we? There we are. So those are the 3 exit statuses that grep can have. 0 if it finds a match, 1 if there's no match, and 2 if it has any kind of error, so a bad pattern or it can't open an input. So grep has a lot of options. You can read the man page for all of them. These are the ones that I think are most useful, and these are ones that I use fairly regularly, so all of these. So when we were talking about extended regular expressions, we were using a capital E to say that they're extended regular expressions. It's not a lowercase e because that means something else. So you can give grep more than one pattern, and it will OR them. So if it matches this pattern, it'll go through, and if it matches this other pattern, it'll go through. So if you have multiple patterns you want to give to grep, you can do it with the -e, because let's try to give it without the -e. So we'll do a grep. First, Well, actually, let's put a cat in front of it so we don't have to deal with this. Actually, let's try a redirect. Okay, foo. And we're going to grep, and we'll just look for the letter A. So there it is, all the lines that have an A. And let's also do B. No lines have a B. What about a Y? All right, there we go. So 2 of the lines had a Y. Now, if I was to try to do grep A, Y, or sorry, grep Y, A like this, grep is going to see the Y as the first argument. So that it knows that's the pattern, but then it sees there's another argument, so it's going to treat it like that's the file name. Okay, and then it says no such file or directory. If I just try to quote it, of course it's not going to work because then grep sees the first argument as y space a, so it's going to treat that as the pattern I'm looking for, and there's no line apparently that has y space a. All right, so if I want to give it more than one pattern, I'm going to preface the first one with a -e, and then I'll close out my quotes, and then I'll say here's another pattern for you with the -e. Get rid of that space. Oh, there we go. And there I've got all the y's and the a's selected. And those are the 3 lines that have both, that have either a y or an a. You can see that this line does not have a y. So that's how you can do an or. So since we're here, I'll show you how to do an and. There's no and operator that you can give grep. It deals strictly with ors. But I'll leave it kind of the way it is. Hold on. So if I want an and, well, if I give grep just a y, it'll only allow the lines with y to pass through it. And then I could run another grep and look for only the lines that contain an a. So I'll just pass it through another instance of grep and run it like that. So the first filter only allows lines that have a y on them to proceed through. And then the second filter only allows the lines that have an a in them to proceed through. So if you want an and, you can just pipe 2 greps together. Right, and in fact, these are the 2 lines that have both a y and an a. So there's a y there, and there's a y there. They're not red because this grep on the left, it knew that it was outputting to something that was not a terminal, so it didn't put color coding on it. But this guy on the right, he figures out that he is outputting to a terminal, so it colorized everything. So these tools will check to see, most of them anyways, am I connected to a terminal or not? And if it's a terminal, then they put color encoding on them because that's actually what the alias is set up to do. I just type to see what the aliases are. Here I can see grep has been aliased to color auto. So if you don't have that, then the text is never colorized. But here it looks at, well, the auto tells it to look at your output. If it's an output that supports color, then make it colored, otherwise don't. So this pipeline that it's going into, it doesn't know where that's going, so it does not colorize it. But this one here can determine I'm actually outputting to a terminal, so it adds the color codes. Can we pipe the y to an a? Yes, that's what we did. Here is the grep of the y, and there is the grep for the a. Okay. All right, so let's go back to this list. So regular expressions describe what you want to match. There isn't really an easy way to say in a pattern negation. Actually, there is not. The only thing we get close to is when we have the square brackets and we say something in this set of characters, we can negate that and say it's a single character that is not one of these things. But there isn't a way to take an entire pattern and negate it, because that's actually very computationally expensive. But sometimes we do want to negate, so we can run a grep and tell it to do the inverse. So when the regular expression is interpreted and when it's compared to a line, it's easy, quotation marks, because it is still complicated, to determine if a line is accepted by the regular expression or not. So we do get a true-false answer from that. And then if you've got a true-false answer, well, inverting it's easy. You just switch the true to a false and a false to a true. So we can give it a pattern and tell it invert the whole pattern. And that's what this -v option does. So let's go back and we'll take a look at this string or the pattern where we're just looking for a y. Okay, so I got grep well, I don't need the -e anymore because there's only one. And let's get rid of, or actually let's put this quote back. Okay, so if I run it, let's add line numbers. So that'll be grep-n for line numbers. Okay, so here I've got the lines that contain y's, and the y's are nicely colored because our grep has the coloring option from the alias. But let's tell it that I want the opposites. So I want the lines that don't match this pattern. So I'll throw a v on there. And I can see now I'm getting lines that do not contain a y. Apparently line 2 doesn't have a y, and line 4 looks to be blank. Yeah, line 4, well, it had 2 spaces. That's why it outputted. Let's take those away. Okay. All right, there we go. So line 2 does not have a y on it. So if we wanted the lines that do not have an a and do not have a y. Okay, so let's try this. Well, we've already got the lines that don't have a y, but it looks like it does have an a. So we can put this through another grep, and we're just going to do, again, a dash v, and we're going to find a's. So we don't want the lines that have a's. And then there was nothing, because the only line that made it through that didn't have a y happened to have an a. The a is right there. All right, what about the lines that, what am I trying to say? Do not have both an a and a y. So then you'd have to think about De Morgan's law. So De Morgan's law is the thing that says the not of an and, or the not of an or, is the, okay, let's just do one at a time. The not of an and is, the not of a and b, the whole thing knotted, is not a or not b. So if we want the lines that contain either neither a and y, or just an a or just a y, but not both, then we should probably apply De Morgan's law. So how can we do that? What can we do? Well, let's just try it with a single grep and see if it'll work. After I said that whole thing about De Morgan, I'm going to just use a single grep. Well, no, I can do that because this is an and. And to negate it, I want... Hey, what happened there? Why is there no n? Did I not type the a? Confused. Oh, no, sorry. That's the negation, the v. Okay. Don't worry if the explanation's confusing. It'll make more sense when I do it. All right, so let's just say I want to negate, and we'll say e for a's and e for y's. Let's see what we get. That did not work. No, because that actually makes sense, because what I said doesn't make sense. Okay. Oops. I've got lag when I'm typing because of the stream is taking a lot of bandwidth. All right, so what do we get when we run this guy? We get all the lines that have both an a and a y. So what if I wanted the opposite? What if I wanted the lines that had neither and a, or sorry, the lines that don't have both? Well, that one's actually quite complicated. It's too early for that one. Let's come back to it. All right, so that's negation. Patterns are case sensitive, so it will be case sensitive when it runs. If you don't want case sensitive, you can use the -i option. So that stands for case insensitive. There's a note here that this is computationally expensive. So if you're just worried about a single letter being upper or lowercase, it's better to put in a square bracket or to find that single letter that may be upper or lowercase. So let's try to find an example in the man page. Man grep. All right, what do we got? Something that might be upper and lowers. Okay, this word generic. We'll search for it. Oh, I need to do that. All right, so we'll run the man of grep, and we'll pipe that through a grep, and we'll look for generic. All right, so it found the line. To demonstrate its case sensitive, I'm going to turn this G into a lower g. Right, so it didn't find that. So there are no lines that contain the word generic, or sorry, the substring generic with a lowercase g. So you can come along and say this whole thing is case insensitive, and then it will find it. But I don't know if you guys noticed, that actually took a little bit longer to run. So how about we take man grep, and then I will time it. This one I don't know if it's going to be big enough to show the time difference. Time. No, that was way too fast. Right, we're not going to be able to see it there. When you do the -i, it does slow it down considerably. So a better solution would be to not make the entire string, or not make the entire pattern case insensitive. It's to come here and say, you know that G I was telling you about? It could actually be a lower G or an upper G. There. So we're telling it that this letter here is either a lowercase g or an upper G, and then it's followed by an eric. Don't worry too much about performance, but if you are using -i's and it's taking a long time, which has happened to me, try getting rid of the -i and only capitalizing the thing that might be capitalized. All right, next one we've got C, it's count, and it says counts the number of matching lines. Note that it says lines. Right, so when we get into later options, particularly this one, -o, this one will show the output differently, but the count option is always counting lines, despite what all of the other options may do. So if we run this again, and I'll give it a -c option. Soon as the lag catches up, there we go, -c. Hey, it says 1. There was one line that has that substring, and we know that's correct because there's the line right there. Okay, so let's change this. How can I do, does this work? Yes, it does. Awesome. That'll help me deal with the lag a bit better. So let's just look for the letter A in the man page. It occurs a lot of times. It's there quite frequently. Okay, so let's count how many there are. Actually, let's do it the old way first. I'm just going to pipe that through word count. Word count -L to tell me the number of lines. And I can see there were 316 occurrences. And it's just indented because my prompt didn't get redrawn very well. There, 316. Okay. So that's using word count, but we don't need to rely on word count. grep will count things on its own. But when we get down to the -o, we're going to have to use word count. Okay, so if I tell it grep-ca, it'll count the lines that match, and it says 316. So on a couple of the questions on the quiz, I think I asked you how many, and using -c is the way to go for most of them. We've already talked about -e, lower e, for multiple patterns. There's an option -x that tells grep, I don't want you to match substrings anymore. I want you to match entire lines. So the default behavior for grep is that it will match any substring on an input line. But if we want it to match the entire line, you say -x. So that's the same as putting the caret and the $sign around your regular expression. Right, -n shows line numbers. So whatever line number on the input this is, it'll put it in the left. And you saw when it was colorized, it makes it green. So let's just run the same one we had before. Because this is a GNU tool, it'll work just fine if I put the option after the first positional argument. And I'm tired of dealing with the lag, so I'm going to start doing that. But you can see down the left is the line number that each of these lines are. All right, so we're not getting the A and the Y. Can we do something like this? grep alpha, grep EVY. I mean, as logic. Yes, but that says, I assume you meant this other guy to be an A. Sorry, I'm talking to Thanos. That says doesn't have either. I was trying to do doesn't have both, if that makes sense. And I'll rephrase that better once we've got more practice with grep. James, yours will work. So what James has said is grep-x, so we're going to match the entire line. And then it says a character that is not a y repeated a whole bunch of times. So the line can have, wait, no, that doesn't work. That's the same. That says absolutely no y's and absolutely no a's. So that is still saying not either of them. I'm trying to do both. So a bunch of y's is fine and a bunch of a's is fine, but not both a's and y's. Okay. -n for printing line numbers, just said that. -H forces the display of file names, and lower h forces it to hide file names. So the normal behavior is if you give it a single input file, it won't display the name, but if you give it multiple input files, it will display the file name, just like it displays the line number. So we can see that if we go and we use the books corpus. So I'm just going to switch into 1280 data. No? Yes. And then we'll go into books, and just to make sure I'm here, I'll do an ls. Okay, and I'm going to check the permissions because I think I have it. No, good, they're good. So I won't accidentally do anything. Okay, so let's grep for the phrase Bob, the substring Bob. I think that was a quiz question. I'll do a star for all of these files. And you can see it has put the file name over to the left of this colon delimiter. And the output, it's purplized, sure. But this could actually be a problem. If my file name contains a colon, then this is not going to work as a good delimiter. But that's the way it is. And we know how to deal with stuff like that using xargs. Okay. Lower h is going to suppress the file names, right? So there was no options. If I give it a lower h, it will give me the same output, but without the file names on the beginnings. Okay, so let's try it changed with not just looking at. Actually, I want to know at least one text that has it in it. So the Adventures of Huckleberry Finn. All right, so let's try looking at the Adventures of Huckleberry Finn, only that one. And I've got no file names because grep knows there was only one input there. If I want to surely show the file names in all cases, I can give it a capital H, and then it will display them. So next, we've got these two. These are very useful. -lower L to list the files that match. So it's not going to show me the lines that match. It'll just show me the files. So I think that's a quiz question too. So let's do a grep. Oops, that's not how you spell grep. Grep. We're looking for Bob and a star. Right, and there are all the lines that have a Bob and all of the text that contain them. I'm going to give it a lower L. And here it's only showing me file names. So lower L will show you the names of the files that contain a line that match that pattern. All right, so if we want to see the opposites, the ones that don't, we'll give it a capital L. And there's the other ones. So notice A Christmas Carol and A Tale of Two Cities are in the list of files that don't have a line that contain Bob, and they are not in the list of files that do contain Bob. Okay, so this is not the same as this guy. So let's make a -v and then a -l. All right, so this actually showed me everything. Right there, well, let's count. How many lines? Word count -l, 15, and then how many files are actually here? ls piped into word count -l. 15. So when I did something like this, I said grep bob star and then dash v dash l, it actually ended up showing me everything. And I thought I was inverting bob. That's not what this says. This says, well, without the v, it says, find me the files that have a line that contains bob. And then when you did the capital L, it's find me the files that do not have a line that contains bob. So that's the actual inversion. So, but when I put this v on here, what grep sees is, okay, grep bob dash v. So you want all the lines that don't have bob. And then you want to find the file names of the things that match that. Okay, so what it did was it looked through all the books, and any of the books that had a line that did not contain bob got displayed. And every single one of these books is going to have a line in it somewhere that didn't contain bob. Actually, most of the lines won't contain bob. So they all match that criteria. So you have to be careful when you're doing inversions what it's inverting. So this inverted the pattern it was searching for, whereas this inverted the, oh sorry, where'd he go? This inverted the file names it wanted to display you. So again, this doesn't work because this says it's filtering for lines that don't contain bob. And every single one of these books will have a line in it that doesn't contain bob. So they all get displayed. So dash L and dash L are the ones you want to use most likely. Okay. Next, we can tell it to stop reading after a certain number of matches. So you could do the same kind of thing with head. You could take your output from grep and then pipe it through head and limit it. But grep keeps running in the background. If it was parallel, it'll fill its buffer, its output buffer, until, well, it'll fill it, and then head will eventually output the lines you want, and then it'll close it, and grep will close because its output got closed. But we could also just tell grep, show me this many. So let's do that again. We're going to run grep with bob and all of the texts. Okay, so there they are. Looks like the first 5 are from Huckleberry Finn and then 1 from Grimm's Fairy Tales. So let's say that we wanted only the first 5 matches. So we could do dash M5, and then grep will show us, hey, how did the Jungle Book fit in there? Did I do something wrong? Let me see. Dash M. Maybe it doesn't work at the end. Let's try that again. Or maybe it insisted on the space. Okay, dash M5. Should show me only 5 matches. All right, it must really want that space to be there. Let's try it. No, it's not behaving. All right, I gotta make sure I'm using the right version of grep. So we'll do a grep dash v. Aha, interesting. Okay, hyphen version. No, it's GNU grep. All right, I'm gonna check the man page. So I'll do a man for grep. And I'll / define dash m. Okay, that's not the one I want. That's not the one I want, so I'll do an n for the next one, and then the next one. Okay, there it is. Dash m is num. Stop reading a file after num matching lines. The input is standard input. If the input is standard input from a regular file and num matching lines are output, grep ensures that the standard input is positioned just after the last matching line before exiting. Okay, regardless of the presence of trailing context, this enables a calling process to resume a search when grep stops after num matching lines. It outputs any trailing context lines. When the dash C option is used, it does not output a count greater than this. When V option is used, it stops reading after that many num launching. Okay, so instead of applying it to individual files instead of the whole stream, I think that's what's happening. So we're going to do a grep dash M1. We're looking for Bob in star. Yes, it's applying it per file. So if I wanted only the first 5 in the entire corpus, I could do cat star piped into grep dash M5 Bob. Right, so there I've got just the first 5 lines from the entire corpus, but I have lost the file names because cat no longer knows, or sorry, grep no longer knows which files are which because it was cat reading the files. Okay. So that was M. Q is quiet, so it will have no output to standard out. I think it still prints errors. But this is useful if you just want to know, is there a match on this file? Because before, we know that the exit codes 0 and 1 are going to determine if it found a match or not, or it's going to show us if it found a match or not. So if we want to use it in a script, you probably want the -q option to tell it that you don't actually want output to display. You just want to know, does this file contain a line that matches or not? So I'm going to try to find a case where I've used that. Although my entire suite of tools is not installed here. So actually, let's just make a new terminal. It'll be easier. Okay, so I'm going to go into the bin directory, because there's a couple scripts there. And we will grep. We're going to use grep to find this thing that I want. I'm going to do a -e in front of it, because it contains a dash in it. But in this case, it's going to be okay. So anyways, grep-q, and I want it to look in all of my sh files. All right, so there's one. In pull assignments, I have 2 examples where I've used grep-q. So what that's doing is it is outputting the first whatever that variable lines of the file f, and that's being piped into grep-q. So it's just going to determine, does whatever's in this variable appear in the first however many lines that is of that file. And something very similar is going on here. So basically, it's looking for some kind of header in this file, and then if it finds it, it's going to do whatever is inside the if. Okay, so back to slides. All right, so the next one's -o, and this is what the manual says. It prints only match parts of a line with each such part on a separate output line. I hope you guys are paying attention and not just playing around. I like that you're playing around, but don't get lost. I skipped that problem because I wanted to get through the easy stuff first. So print only a matched part of a line with each such part on a separate output line. So let's take a look. What do we got? Let's do something more substantial in this file foo. We'll say I am a line. I am another line. And then none of those are going to do what I want to show. We'll say line, lines, liner. Oh, also lined. We can do that one. And how about linear? Okay, that's a good line. And I don't want the blank. All right, what do we got? Okay, so let's cat foo. And what do you mean there's no such? Oh, because I'm in the books directory. No problem. We'll go back to just the environment directory. Okay, cat foo. There we go. It says I'm a line, I'm another line, and then line, lines, liner, line, linear. All right, so let's pipe that through grep, and we're going to look for line. Okay, so all 3 lines contain the substring line. This one has it here, this one has it here, but this one there appears multiple times. Okay, so I could ask you a question like, how many times does a substring line occur in the text? So you could say, well, that sounds like a problem for the -c. So you could give it the -c, and then it's going to tell you 3, because there were 3 lines that contained the substring line. Now I regret using line. Right, but there's 3 lines of the output. That's why it says 3. But the question was, how many times does this substring occur? And that substring occurs multiple times on some of those lines. You could do some trickery with tr, but if you do, I'm always going to come up with a case that breaks it. So what we really want is it to display its output differently. So if you do -O, it changes the output where it's going to display every match, but each match gets displayed on its own line. So there I've got a line on its own line each time. You can see there's more than 3 of them. And how many should we have? So we should have 1, 2, 3, 4, 5, 6, 7. So I can then take the output from that and pipe it into word count -L. And there we can see it said 7. So if the question is, how many times does a substring appear in the files? Well, you do it like that. You run grep, you have it output each match on its own line, and then you count them. So 7. Okay. The next thing is, if you're doing this to search through a man page, you'd probably don't want individual lines. So let's try that. So we'll do a man of grep, and we'll pipe that through grep. And I would like it to find all of the -Ms. And of course, I mistyped because I was thinking M when I was typing. Okay, so if I do this, we're going to have a problem actually. So I run it, and grep is angry. It says, you have to give me an argument with that option. So when grep gets this, you have to remember what the shell does with these things. So the shell, if we only examine the right-hand part here, the shell's going to look at this, and it's going to go, oh, that's quotation marks. I'll take those away. And then this thing is the first option you give to grep, and the shell is perfectly happy with that. But then grep receives this, and it sees, oh, you're giving me an option -M, so it doesn't know that I intended this to be the pattern, because it actually does have an option -M. That's the one that limits the number of matches. We were just looking at it. To use that one, though, you have to give it an argument, so you have to provide a number after it. So grep is saying, I don't know what you're talking about. I know all about -M, but you're supposed to tell me how many things I'm matching. Okay. So we have that general problem with arguments if we're trying to pass a positional argument that starts with a hyphen. So 2 ways we can solve it. We can do the GNU way that works most of the time, where we give it 2 hyphens in a row, and all of the GNU tools recognize that to mean the thing that follows is not an option. It's actually a positional argument. So when grep sees that, it will know that I mean that's the pattern. Okay, so there's all the lines that contain -M. The other way we could have solved this, though, sorry, I got to count because I'm getting so much lag. Oh, and I miscounted. Okay, the other way we could solve this is we could put the -E. So when we're telling grep -E, it means the thing that follows is a pattern. It's not anything else. So when it sees this -E, it will then know that this -M is actually a pattern and not an option for it. Okay, and we get the same output. All right, but there's an issue with this. I'm going to throw line numbers on it, -N. So I got a lot of individual lines, but I've lost all the context for them. Like this one right here, line 164, it tells me groups of matches with the -O or the only matching option. This has no effect, and a warning is given. Okay, well, what came before that? I have no idea, because the line it showed me right above it was 159, because the line that comes before it didn't contain a -M, so it didn't show me. So, I mean, it's doing what it's supposed to do, but it's not very useful for me right now. So that's what these next 3 options are. -C stands for context. A is after, and B is before. So you would use each of these options, and you would give it a number, which would indicate how many lines of context do you want. So context will show me lines above and below. So if I said -C2, it will show me the 2 lines that occurred before a match and the 2 lines that occur after. Likewise for A and B. If you say -A2, it shows you the 2 lines after. If you say B2, it shows you the 2 lines before. So let's just grab the context, because that's the most, or it's the easiest one to deal with. All right, so I've got all of this stuff is the same, except I'm going to tell it I want 2 lines of context. Okay, now you can see it's given me a whole bunch of matches. If we look right here, line 179, that's the one that has the -M, but I told it show me 2 lines of context, so it's showing me the 2 lines before, and the 2 lines after. And whenever we have these things separated, they use this hyphen hyphen as a separator. So it's going to show me lines 177 through 181, and then tell me that this next bunch is not a neighbor to it. It's a little ways away. So you might think, well, why is it doing that? It's pretty obvious with the line numbers. You have to remember, I turn the line numbers on explicitly. So if we take that away, we can see that it is actually useful to see those separators. Right, so here is 2 lines of context. So first one, second one, before the -m, and the 2 lines of context after. Now down here, though, I can see it gave me a whole bunch of lines all grouped together. So let's run it with the line numbers, and we'll be able to see why. So the other thing to note in this column, the delimiter here is different. So the lines that actually contain the -m have a colon in front of them, and the lines that don't, the ones that are provided for context, they have hyphens. So I can see if I go down here, I can see I got 3 lines that don't have a match, and then there's the next match. Actually, let's talk about this one first. So here I've got the 2 lines after this match, and the 1 line before. But then I've got another line that matches. Now here I've got these 3 lines of context. So the question might be, why is it showing me 3 and not 2? Because I asked for 2. It's actually because those 2 contexts overlap. So 365, the 2 lines before it are these 2. So that's showing me that. And 361, the 2 lines after it are those 2. So they overlap on 363. So this is a contiguous set of lines, given the context that I've asked for. Okay, so the A and the B, the before and the after, they work just the way you would expect. Instead of both above and below, they just show you before and after. Right, sometimes we might have an extremely long and cumbersome pattern. You can have a grep read the pattern from a file. Sometimes you would want to match a literal string, so that's actually fairly common. And your literal string might have meta characters in it. So you can give it to grep and then escape them all appropriately. But if you know it's a literal string and not a pattern, you could also say capital F to say that it is a fixed string, not a regular expression. Lastly, there's this one, W. I'm hesitant to mention W because it doesn't work the way you think it does, but I know you guys, if you Google or if you read the man page not closely, you'll think, oh, W matches words, I can totally do that. And then if I ask you, find me the words that blah, 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 then you think it'll behave the way you want it to, but I'll demonstrate that it doesn't. So let's go back into the books folder. Okay, we're back there. Let's say I ask you to find me all of the words that start with an E and end with an R. I have no idea what those words are. So we can run a grep, and we can tell it, we'll give it 2 quotes, so words that start with an E. Well, I'm not going to bother with the angle brackets. I'll just have a word boundary, E, and then here's where the problem arises. Dot star, what did I say, R? Yeah, and then a word boundary. And I'm going to pipe this through head because I know there's going to be a lot of them. There's not? You're kidding. Oh, it's reading from standard in. I didn't tell it what to read. Okay, so we'll just go back. And we'll put a star there. Okay, so it didn't work the way I wanted. So let's take a look at this. What I said was we got a word boundary and then an E, so let's find it. There it is, each. Okay, and then at the other side I said ends with an R, so you'd expect this line to be rejected because that H is not an R. The problem is, though, that I said dot star, and dot star allows non-word characters. So really, the thing that matched was that substring there. This is the way that -W behaves. So if you were to give it, say, a pattern, where are you? There you go. R star dot E. Okay, so if I was to give it this pattern and say -W, It's not going to restrict the match to a word. All it does is it puts the /b's around it. So it's literally taking this pattern that I give and turning it into that, which does not behave the way that I wanted it to. So I'm going to run it and we're going to see the exact same output. Right, and there it is there. So even though I said match words, it doesn't. It just put word boundaries on either side of my pattern, on the left and the right. And then I have this problem where it'll find any E that is eventually followed by an R, regardless of what's between them. So here we've got another one, entreaty, and then weather. So it matched that substring, even though I said I want words. So -w doesn't restrict it to words. It just puts the two word boundaries around it on the left and the right. So if I really want to find words that start with an E and end with an R, the problem is I can't have it match anything. I can only have it match word characters, like that. Okay, now we've got different outputs, but here I can see executor. That's an E and an R with word characters in between it. Ever, that's another one. It looks like it's ever on most of the lines, actually. This one doesn't have it. Earlier, and ear. Okay, so the problem was this dot star ruined everything. So again, -w does not restrict the match to be a word. It just puts word boundaries on either side of the pattern that you've given it. That's also why it's last, because we have to talk a lot about it. All right, we've already seen -e for matching multiple patterns, and we've also seen it for matching expressions that start with a hyphen. So if I want to grep for -m time, grep is going to be angry because it'll tell me that the option m, giving it a t, doesn't make any sense. So it was mad. So to tell it, no, I actually mean that's a pattern, I say -e in front of it, and then it knows that this is the pattern. Okay, so another example with -o. Oh god, she sells seashells. If I grep -o that for the E, it will output all of the parts of that input string that match the pattern once per line. So it had 4 E's apparently. If I want to count them, I word count them, and it says 4. But if I say C, again, grep always counts lines. It's always talking about lines. The O is only changing the way that it displays the output here. It's not changing the way that it matches things. So yeah, it says there is one line that matched. All right, so let's say that we want to do some practical grep things. If you only want to see what directories are in a directory, we could take the ls-l. We know that the first character output from ls-l is going to indicate the type of entry the thing is in a file system. So all these started with a hyphen because they're regular files. So let's go up one directory and do an LSL. All right, so there we've got corporate ipsum, Pokemon CSV, and words.txt. Those are regular files, the bottom 3. And then the one above it, it's got a D here. That means it's a directory. So if I wanted to only see directories, I could do an ls-l, and I could pipe that into grep, and I could say, show me the things that start with a D. And there, it's only shown me the directories. And again, it's just indented because my prompt's a little funny. Okay, so this works casually, and it works in an interactive environment. It's not the best way to do it in a script. If you read documentations for ls, it's pretty explicit that it says you should not be using the output of ls in a script to control things. You should be using find instead. Don't worry about it for this course, but just know if you're writing robust programs, you should not be piping ls into things, or at least not ls with any options on it. You should use find. Actually, no, you should not be piping ls into things in a program because it'll break for any file names that contain a new line character. And actually, let's do that. Let's break it. So I'm going to go back to the environment folder. Okay. Let's see if I can do this just from touch. Let's do a touch. And remember we did this before. Let's create a file called file, and then, I don't know, dude, file dude. All right, so now I've got a file that has a new line character in its name. So if I do an ls, we can see right there, it's escaped it for me. It says there's file, and then there is a new line character. So this is the way that you can escape special characters in Bash. It doesn't work in SH, but this is saying the thing that's quoted is an escaped character. It's a special character. And then that's followed by dude. But my output, let's see it from LSL. Whoops, sorry, I copied -n there. ls-l, it should be the same output. Yep, there it is, file dude. Let's take that and pipe it into cat. So now ls will know that it's part of a pipeline, and we can see it's on two separate lines here, file dude. So you can see the problem if I was to try to use grep. So now let's try using that same grep command. Where'd he go? That's it right there. LSL into grep, and I still got dude. So let's do that. ls-l piped into cat to see what happened. And there it is there. So when it got piped into cat, it knew it was part of a pipeline, so it didn't do this nice thing for us where it escaped it. Because when it's running up here, it knows that it's being run interactively. So a user typed the command, and the output was to a terminal, so it formatted it nicely for a user. But down here when I ran it, it knew that it was part of a pipeline, so it didn't do that stuff, and it actually just printed the literal file name there. There's other options we can give it to ls to force it to quote things, but we didn't do that. So my attempt at only listing directories here failed. So that's why you shouldn't do this, but for this class it'll be fine. I don't expect you to handle new line characters in file names. I do expect you to handle spaces though. So I'm going to get rid of rm file $dude. That should get it. Yeah, it's gone now. All right, here's another one. Find the files with write permissions for group users. So this hyphen says only find me the files, and then what have we got? This must be the owner's first 3 dots, and then the read permission for user or for group we don't care about. Well, the only thing we care about is write permission for group. So I've got some examples, but because we're working off of the slides that are on D2L, the answers are right there. So the questions are, what do these commands do? So we've got grep of ABC. Well, grep is going to interpret this. A is the first argument, so that's the pattern. And then it has 2 more arguments, B and C. So it's going to interpret those as file names. So what it'll do is it will find the lines that contain an A in the files named B and C. All right, this next one has grep, and it looks like it's looking for an HTML tag with its 2 angle brackets, and then foo. So the intent, I believe, was to find the beginning HTML tag in a file called foo, and apparently it must be capitalized, because remember, this is case sensitive. But grep will get angry at this, and it will say that there's no pattern, which is kind of weird. So that means grep did not receive a first argument. But what's happened here is these are shell meta characters, right? Those are the redirectors. So this says to the shell, open a file called HTML and put that as grep standard in, and then take standard out and redirect it to foo. Right, so assuming there is a file called HTML, which is not a given, but it looks like this case assumed it, grep is going to run, and when it runs, it'll see no arguments because the shell interpreted all of these things. So when grep ran, it didn't receive arguments. That's because the shell interpreted those meta characters, so if we want to actually give them to grep and tell the shell not to interpret them, you have to quote them. All right, this next one, grep, and then it's quoted this time, so that's good. Star star, foo. Well, the first star is at the beginning of the pattern. So normally star means 0 or more of the preceding pattern. but there is no preceding pattern here. So in this case, the first star is taken as a literal star character. All right, then the second star, well, it'll interpret that to be a clean star because there is something in front of it. So it's going to look for 0 or more star characters. And that's going to match everything, because every line will contain 0 star characters. Even the ones that have many, they still have 0 somewhere. Hold on a second. Where is my... I'm going to mute it so you don't... Next one, we've got grep star. So what this does depends on what this glob matches. So if the star is going to match multiple file names, then grep is going to look for lines that contain the first file name in the remaining files, because it will receive this as a number of arguments. And the first argument will be the first file name, so it'll take that to be the pattern. And then the remaining arguments will be all the other file names, which grep will interpret as file names. So it'll look for lines that contain the first file's name inside of all of the other files. All right, but what if star expands to only be a single file name? Well, in that case, grep will interpret the file name to be the pattern it's searching for, and then it will see it hasn't been given any other arguments, which means it's going to run as a filter, so it'll start reading from standard in. So it's going to look for the first or the only file name on the lines of standard in. All right, what if there are no files in this directory? That's actually dependent on the shell's behavior, so I'll only talk about the default behavior. So the default behavior of the shells we're using is that if nothing matches the glob, then the shell leaves it alone as a literal. So example, where are we? Here we go. I am going to make a directory called test, and we'll go in there. And I made a directory so it would be empty because I don't want anything to match the star. I'll run args.sh, and I'll give it just the star. All right, so when that runs, the first thing that does happen is that the shell sees the star. It knows that that is a glob. So it's going to expand that glob to match all of the file names in the current directory. The thing is, there are no file names that match that glob because this directory was empty. So the default behavior of the shell is that it then leaves the glob as a literal, so it doesn't replace it. So then we can see that args received star as its first argument, and that was its only argument. That behavior can be changed. There's an option on the shells which will tell it that instead of leaving the glob in place, it will actually replace it with empty. But the default behavior is to leave it in place. So if args.sh sees a literal star, then that's what grep will see as well. So when grep runs, it will see that its only thing it's given in the pattern is a star, and a star at the beginning of a pattern means literally a star. So then it's going to show us the lines that contain a star. I'm going to pause for a moment. Does anybody have any questions about what we've done so far before we get to back references? All right, let's get back to that problem that I skipped, actually. So what I want is to see lines that do not have both an A and a B. So that line should get rejected, and that line should get rejected. Okay, but this line should be okay. No, not that line. That line should be okay, and that line should be okay, as well as this line. So lines 1 and 2 should get rejected, but lines 3, 4, and 5 should be displayed. All right. So we're allowed to have A's. Oh, sorry. And we're allowed to have B's, but we're not allowed to have both. Can't have both A and B. Okay. So let's get out a test. And we'll rm-rf test. Okay, we'll cat foo. We'll cat foo and pipe it into grep. So A's are allowed and B's are allowed, but not both. Okay. Also, we're allowed to have lines that don't have either of them. All right, so the way to solve this is we're going to say we're allowed to have all lines except for the lines that have an A that is eventually followed by a B. Okay, and then we're also going to do the other way. But let's just see this one first. So I've now lost the line that had AB, but BA is still there. So we'll pipe that into another grep, where I'm going to say all lines except for the lines that have a B followed by an A. So what does it say? It says you're not allowed to have an A and then a B, and you're not allowed to have a B and then an A. And we get the lines that are okay. The ones that are just A's and any other character that's not a B, that's fine. The lines that are just B's and any other character that's not an A, that's fine. And also the lines that have neither of them are fine. It's just we're not allowed to have an A that is eventually followed by a B, and we're not allowed to have a B that is eventually followed by an A. Yes, so let's demorganize that. It's not going to help us though. So we'll do a cat foo. All right, so if I was to demorgan it, it will be the opposite of this output. So it'll be the opposite of grep of an A eventually followed by a B. And I've got to say dash E here. Dash E. Or a B eventually followed by an A. All right, so if I wanted only the lines that had both an A and a B on them, this would give me that. Oh, it's not going to work because I don't have a space. Hey, what happened to that E? Nope, too laggy. Right, so those are the bad lines. Those are the ones I don't want. And then this is the De Morgan version of it. So this is an OR. To negate it, I want to negate the whole thing, but there's actually, I'm not sure if I put a V on there if it'll work. Let's try. Yeah, it did work. Oh, that's great. So that works too. All right, so what do I have here? I've got not this one or not this one, which is the same as, oh, that's not right. What do I have there? Because this is not something and not something. Yes, that's right. So I got not something and not something, which is the same as not the two somethings ORed, which is what this one is. Either way is fine, in my opinion. I guess this one is slightly better because it only has one process, whereas this one has two. But it doesn't, on Unix, that's not a big deal. Unix is made to have lots and lots of processes running. All right, so our next problem to look at are back references. So what if I wanted to say something like match lines with two of the same word characters in a row? Or even match lines that contain the same word twice? So I don't have a way to do that presently, because if I was to try to solve this problem, two of the same word characters in a row, I could try /w/w, but that doesn't work because each /w will match any word character. All right, I also cannot use the, what are they called, curly braces, because its curly braces would literally translate into this. So let's try it. I'll just use foo as my input because it's controlled. I'll do a grep, and let's say that I'm looking for /w/w like that. So you can see it didn't work. It's giving me these lines, which it should give me, because those are the two of the same in a row, but it's also giving me all these other ones. So you might ask, why is everything highlighted? Because it's showing me each pair. So HK, GK, and YG, those are the pairs. But I actually wanted them to be the same word characters. All right, so let's manipulate this and see if we can fix it. Okay, we'll do a, what was I going to do there? A -E? No, the other E for extended regular expressions. So let's do as much manipulation as we can. Let's try to group this guy. And then let's try to say 2, because I want 2 of whatever that thing is. Okay, it didn't help. I got the same output. Because ultimately it comes down to, or rather, what this thing is doubling, it's actually doubling the /w. So it's /w/w. So that's not what we want. The W will allow any word character. I want it to be the same word character. So we actually need new meta characters to do this, because we have no way to remember things from a regular expression. And actually, if you try to remember things in a regular expression, it's no longer regular. So regular expressions describe regular languages, and regular languages have limitations on them. The limitation is that they can be recognized by a finite automaton. So the problem is that a finite automaton can't really remember anything. It can remember stuff, but it can't decide what to remember at runtime, because it has a finite number of states where it could potentially have to remember an infinite number of things. So anyways, that is trivia if you take theory of computation. But remembering things is non-regular, so they've had to add extra stuff that kind of wreck the idea of a regular expression. But it's fine, we can use it, because our computers, well, actually they are deterministic finite state machines. They just have a very large number of states. Okay, anyways, we can capture matches with these round brackets. And remember, round brackets are part of the extended regular expressions. And then you can refer to them later with back references, so these numbered back references. So if I actually want, hold on, I got a question. If we have 2 with comma, it means exactly 2. The 2 means at least 2. So just 2 comma would mean at least 2. And 3 comma 4 is 3 or 4. The 3 or 4 is right. With no comma, it would mean exactly 2. But remember, even if you say exactly 2, if you don't restrict what's on the left and the right of it, more of them can sneak in on the left or the right. So the way to get it to remember things is to capture it, like I have in this little grouping. And then whatever matches the /w, it'll remember it, or it'll remember everything inside the round brackets. And then I can refer back to that with /1. So 1 refers to the first capture group. So now if I run this, I only get the lines that had duplicated letters. So here's the first pairing of duplicates, AA, and then here is the second pairing, AA. Likewise here, BB and BB. Those don't have to be all the same. So we'll go in and we'll throw an AA there, some more garbage, a BB there, and let's throw in an FF as well. Okay, save that. Going back. and running it. So here you can say it's highlighting all the pairs of letters. So there's two A's, there's two B's, there's two F's. So this way up here didn't work because all that would say is /w/w. Right? It doesn't say that they have to be the same /w. This is saying there's a word character immediately followed by itself. Okay. So the next one, or the next example on the slides, is about looking for 6-character palindromes. So /1 matches pairs. I'm not sure what you're saying, but the /1 refers to whatever was matched in here, whatever it may have been. So when we're looking at this input string, first thing the machine's going to do is it's going to look at this H. So it'll say, okay, that W is the H. And then when it says /1, it remembers that was the H. But that's not HH, that's HK, so that's no good. Then it looks at the K and then the G and blah, 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 until it gets to the A. So it remembers the A right here. Where'd he go? Right there, the A. And then it says the next character is whatever was in here. That was the A. So there's another A, so that's a match. Because we had this word character followed by itself. Is this computationally expensive? Thinking. I'm thinking. No, this is not expensive. Because all it's going to do is find patterns that match something in the string, because this could be any pattern in here. And then once it finds a match, it'll go and it'll store it in its memory at position 1, right? It's like a variable named 1. And then it looks for that literal anywhere in the string, or where it's supposed to be in the string. I mean, it is computationally expensive in that, you know, there could be multiple things that could match inside of these round brackets, so it has to try all of them. So it does add complexity that way. But once it's found something, it just remembers it and treats it as a literal from then on. But because it's a machine that always makes the right choice, it does have to go through all of the choices to see which one is the right choice. So it does add some, well, quite a bit, but it's not going to be an issue in most cases. So to get 3 in a row, you would do 1, 1, not 2. Yes, you would do 1, 1, not just 2, because actually there is no capture group 2 here. So the 1 is referring to the group of the round brackets. So let's try that example. I'll do a 1, 1. And there it says, well, there's 3 in a row, there's 3 in a row. If I try to put in a 2, then it says invalid back reference. There is no capture group 2 here. There's just the one set of round brackets. Okay, so let's run a grep again with the next example. We're going to say it's an ERE, and we're going to capture, let's do 3-character palindromes. So we'll do a /w, and actually let's do 2 or 3-character palindromes. So there's our /w, then we'll say maybe there's another one right there, but it also must be followed by /1. All right, so it's reading from standard in. If I give it ABA, then that's a match, because the A is the outer, the W is the B, and then the A is the last one. We could do, let's try DDFD. So that contained, oh, bummer. DD is a match. Let's try something else. AWFW. There we go. So the WFW matched. This one, the DD's matched because, well, what did it do? It says, what's this first thing? I'm going to make it this first D. And then it says, okay, we'll take that question mark to be the empty string, because this can match 0 or 1 thing, so it chose it to match 0 things. And then that has to be followed by whatever we put over here. That was a D, and yes, it is followed by a D. So that is a match right there. It did not show me the DFD because it had already used the D. Okay, let's give it something bigger. Let's do a G. Oh, I can't because it's going to match anything. TTG, then it'll match the two T's. Okay, so that one isn't as fun. Let's do a different one. This guy, let us match. Okay, so let's match palindromes that are exactly 4 characters long. So we'll do -2. Okay, so AA, and then, well, let's just do 4 A's first. That's an easy one. They all match. ASSA, that's a good one. Let's do a different one. ARRA. All right, those matched. Let's try ARAR. No match. All right, so let's trace this one, ARRA. It says, okay, this first group, that's the first A. And then the second group here, that's the R. Okay, so we already decided that it's in the A and the R, so the second group was an R, so that had to be an R. And then the first group has to be an A, and that's an A. And then we'll try this one next. So as it's trying things, it will say, all right, we'll put the A here, and then we'll put the R here. So the 1 is the A, and the 2 is the R. But I said 2 here, so there has to be an R there, but there's not. There's an A, so that one's rejected. And then it's not even going to bother with the other ones because it sees there's only 3 characters left, and I required it to have 4 characters. So that's not a match, that's a reject. And I believe this example on the slide is for 6-character palindromes, and here I was actually careful and put word boundaries. Can I make the window not cover the outputs? Well, let me see. Oh, sorry, is my ugly face is on top of the outputs? Let me look at that. Oh yeah, I see. Okay. Let me drag that over a bit. All right, you guys should have said something earlier. Okay. Sorry about that. I think I pulled it over for one of the greps that put line numbers on things and didn't think about it. Okay. Okay, so that's enough about grep. It's really, we introduced this concept of back references, and we also just talked about these options and the funny options that work a little strangely, like the -O and the -C and -E for giving it multiple patterns. And this is a long list of options, but I have fairly regularly used all of these. So these are my options that I use a lot. There are probably other ones that other people use that I just don't know about. Does anybody have questions about grep before we take a look at sed? All right, let's take a 5-minute break. We'll resume at 4 o'clock. So I will add a scene that says that. All right, so I'll see you guys back in, well, 4 minutes now. Okay, so audio's back, except, oh, that's terrible. Okay, so I'm back. Sorry, I turned the monitor on, the audio monitor, and it was, well, I was listening to myself delayed and it was awful. Okay, so we've covered grep pretty extensively. I think we should not start a new thing. I think we should just stick with grep. So you have a quiz. Does anybody have any questions about the quiz questions that I gave you for grep? Because it was meant to be a pretty extensive review. Doesn't seem like anybody has any questions. That means it's all going great and nobody had any problems? I don't think so, because some of them were a little challenging. Good job, Thanos. At least somebody's responding. All right, so basic regular expressions with words. How many words contain an E? All right, so that input file has one word per line. So all you have to do is grep it for an E and then word count it. Or you can use -C. Either one will be fine. How many lines contains exactly 3 E's? What is the line number on which that word occurs? Ugh, looks like that got out of order. That is not supposed to be in there. Hold on, that's supposed to be somewhere else. Where is it? Which one's it talking about? How many words contain 7 or more? Of the words that contain 7 or more. That's supposed to be after this one. All right, so I got to move a question from the first section to the second section. All right, gotta exit. I'll come back to your question as soon as I fix this quiz because it has an error. Not surprising. Question 7, the question, what is a line? Oh yeah, that's the one that I'm fixing. That was supposed to be moved to a different section, but apparently it didn't go. So I'm going to move that into extended regular expressions. We got to put it in the right spot. Okay. I did click save, right? I have to click a whole bunch of buttons to make this happen. Exquisite. All right, let's try this again. Preview. All right, let's look at this. All right, how many words contain 3 or more? How many words contain exactly? And then down here, EREs. Of the words that contain 7 or more, which is the longest? What is the line number? Okay, that's what that's supposed to be. All right, so that question is out of position for you guys. I think it's number 7, and it won't be in the right position unless you start a new quiz, which you can do if you want, or you can just remember that it's supposed to go after the one that's asking for this longest word that has 7 E's. You can email me. I'm quite behind on my emails, but you can try. I should figure out something for office hours. Do you guys use Discord? Okay, so I'll figure something out to make office hours on Discord. And I guess I'll hold them tomorrow. I think, yeah, because I haven't had them all week. So sometime I'll post an announcement about office hours over Discord moving forward. And I'll have some tomorrow for to make up for this week. So does anyone have any general questions about the quiz that we could do together? All right, so I'm going to pick one so that we do something with these last few minutes. Which one? This is an interesting one. Okay, one of the books contains more occurrences of the substring Bob than the others. Give the line number of the last occurrence of the substring Bob in that book. Oh, that one's not too difficult. Let me look at some other ones. All right, let's do this last one. It requires both 28 and 29. How many times does any word that starts with an A and ends with an A appear in the corpus? All right, and what hint did I give you? Okay, I just gave you the outline of the numbers. All right, how many times does any word that start with an A and end with an A? Okay, so I'm going to close this terminal and go to a different one. Actually, we'll just start a new terminal. Okay, CD, oh, no, that's not where it is anymore. So CD, what is it? 1280 data? 1280 data, yeah. And then books. And then I should close the repository out. So we're looking for words that start with A and end with A. All right. So we'll start off with the cat star. And I'll pipe that into a grep. and I don't think I'll need an extended regular expression for this. So words that start with A and end with A. Well, there's a word boundary, and then there's an A, and then there's any number of word characters, including 0, and then there's an A, and then a word boundary. Okay, this has a problem, but we'll see it. So I'm going to do the head just so I can limit the output. So which word started and ended with an A? Pull down and some area. There we go. And that's a word because the hyphen's not a word character, so that's a word boundary. All right, alpaca, good. Whatever that is. Albata. Can I do 2? Do you mean 2 examples, or do you mean question 2? I mean 26. All right, I'll finish off this one because I've already started, and then I'll do 26. All right, so there is a problem with this. You might not spot it, but this pattern here, it requires there be at least 2 characters. All right, there has to be an A, and then there has to be another A. So we miss just the letter, or just the word A. So there we got the output with just an A, but that line showed up because of alpaca, not because of a. So the word a does start and end with an A, so we should be including that in our output, and we missed it. Okay, so we need to fix it. Well, one way we could fix it is, hold on, I gotta deal with the lag. Okay, so we could turn this into an extended regular expression, and then I'm gonna group this entire thing over here, like that, and then I'll OR it with the word like that. Okay, push that through head. I have different output now, but there, that contained and that contained and that contained So now we're getting all of the individual ahs. All right, so I consider that acceptable. You can finagle this to make it even better. So let's try that a little bit. Doesn't matter because this worked, but just for a demonstration, we'll try to make this a little tiny bit better. Well, one of the things that I notice is I can factor quite a bit of this. All right, so there's my first A. Whoops, not anymore. This part doesn't need to be in round brackets anymore. Let's take that out. Nope, so laggy. Okay, so I've got my A, but that might be followed by a whole bunch of word characters and another A. Right, but it doesn't have to be. Could be just the A, but regardless, there has to be a word boundary there. All right, so that should say the same thing. And yeah, that's the same output. That's not a very extensive test, but I believe that that's right. We've got a word boundary and then an A, and then maybe there's a bunch of word characters and another A, but not necessarily. But then there has to be a word boundary. So that should capture all of the words that start and end with A. So we only need 2 A's if it's 2 or more characters long. Otherwise, 1 A is just fine. Okay, so the first question was, how many times? Okay. Ooh, that's tricky. Note it says, how many times is any word? Okay, so we could try to just count them, but that's not going to work. All right, so it says 21552. If I go back to the quiz is saying 2 something 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 9. All right, so the reason this didn't work is you have to remember this counts lines. Some of these lines have more than one match. So if I go up here, I can see alpaca and that line had 2 matches. So that should have counted for 2, but it's only one line, so -c counted it as 1. Okay, so -c is not going to work. What will work, though, is if I give it a -o, and then let's just see what that does. We'll do a head -20. Okay, so now I can see each match is on its own line, and, well, let's do a little bit more than that. Let's do 50. Try to find a word that has... Nope. All right, you know what? We've got a tool that does this for us. I'm trying to show a word that's longer than just one character. And the tool we have that does that is grep. Right, so I'm going to tell grep, show me the lines that are at least 2 characters long. And then I'll pipe that into head so that we don't get overwhelmed. So there they are there. Area, alpaca, albata, aorta. I remember those from our previous output. Okay, so that should be an output 1 per line of all the words that start and end with A. I didn't ask for uniqueness or anything, just a total count over the whole corpus. So we'll do WC-L to count how many lines of output there was. And it says 24729, so that matches what was expected. So that's that one. Okay, the next question is, what is the sum of the lengths of those words? All right, well, we have all the words being outputted, 1 per line. And basically, I have to count how many characters there are. So we got to think, what tools do we have that count? Well, we've got word count can count things. It can count bytes, words, or lines. Other things that can count. Oh, we had 2 things that could count before. What was the other one? Unique. Unique can count things. Unique's not going to help me. We also have grep that can count, but it's not. Well, we could use it, sure. What would that count, though? That would count lines. So we're still back to the problem. I need to count characters to figure out the sum of the lengths, because the length will be defined by characters. So I'm going to choose a word count, and I want it to count bytes. So I think M, or you could do C if you want it to be Unicode safe. At least I think it would be. All right, so I got 49551. That is not going to be correct. No, it's supposed to be a 2 and a 2. Okay. That is way off. Did I do something else wrong? I don't know. We'll find out. The problem is this output also has a lot of new line characters in it. So right, each one of these is an A followed by a new line. Right, so that's a lot of new lines that I was not supposed to count. So how can we get rid of those new lines? What tool do we have that can remove characters? Yeah, tr is correct. So right here, before it gets to word count, I'm going to tr-d, tell it to delete all of the new lines. Pipe that into word count, run it, and there, started with and ended with a 2. So it's probably right. Okay. Cut, I don't know how you would use cut to do that. It's definitely tr, that's what tr is for. So that's that one, both 28 and 29, and we had a question about 26. Display the single line with the most question marks on it. Oh, that's a fun one. I like that one. Okay, so there's a hint, but I'm not going to look at the hint. I hope not, because I wrote the hint. All right, so we can do this manually or we can do it programmatically. So I'm going to start doing it manually, and then I will write a little program that does it. So I want the most number of question marks. So we'll start off by adding all of the books into a grep. And then I will tell grep I want it to look for question marks. So if I tell grep to look for question marks, let's try 5. 1, 2, 3, 4, 5. Problem with this is that's 5 question marks in a row. So that is not going to help us. Actually, there's a bunch of ways to do this now that I'm thinking about it. Well, I'm looking for question marks, and they can have anything in between them. So I could say we could put question mark there and a dot star, and then we could group these together like that. And then I've got a grouping now, so that means this is an extended regular expression, so I have to tell grep that it's an extended regular expression, like that. Okay, and well, that'll show me all the lines that contain 1. Let's find all the lines that contain 5. I don't know, that's a good place to start. Oh, totally didn't work. Stop. Oh, because question mark is it's a meta character in extended regular expression, so I have to escape it. All right, so let's try that. So we got to try escaping question mark. That's not what I wanted. So laggy. There we go. Nope, wrong side. All right. So the lines that have 5. Okay, there's 2 of them. So I want just 1 line. Let's see if there's a line that contains 6 of them. Yes. And there's only 1, so that's the line. So we're going to take that guy and pipe him into Shasam. And that is our Shasam, which is correct. It started 480. Okay, so that was a way to find it with trial and error. Let's try to not use trial and error. Let's have it figure out what the correct number is supposed to be. There's a couple ways you could do that. I think the path of least resistance is going to look something like this. We're going to cat all the files, and I'm only interested in question marks, and I know that word count can actually give me lengths of lines if I ask it to. So let's use that. Before I use it, I should probably show you in the man page. Man word count. We've used it before. It was in a lab previously. So let's do / L. There we go, maximum line length. Prints the maximum display width. So it's going to show me the longest line, or it's going to give me the length of the longest line. Right, so, but I can use that to count the number of question marks on the longest line. So I'm going to do a cat star, pipe that into tr, tell it to delete the complement of literal question mark. Okay, and I'm just going to take that and pipe it into head. It's probably not going to show me anything because I doubt one of the first 10 lines. Uh-oh, that's right, it also deleted new line. I have to have it save the new line as well. Too far. Okay, let's have a look. Yeah, so the first bunch of lines did not contain a question mark. I'm pretty sure this is going to work, though. Let's pipe that into word count with a capital L, and that is not word count. Word count with a capital L. So this is going to show me the length of the longest line, and it says 6. So apparently, one of the lines has 6 question marks on it, and that is the line that has the most question marks. So let's take that, and I'm going to put it in a command substitution, like so. I'm going to assign it to a variable. We'll call it most Qs for most question marks. It's not a very descriptive name, but it'll serve my purpose for now. So if I echo out $ most Qs, there we go. It contains the 6. So now I want to find the line that has 6 question marks on it. So do a cat star, pipe that into grep, tell it it is an extended regular expression, Okay, we're going to quote our pattern because it's going to contain meta characters. And we're going to be looking for literal question mark followed by anything. And that's going to repeat 6 times. Well, I used the wrong quotation marks because I have to do a variable substitution. So I'm going to have to fix that. But we're looking for most Qs, double quotes. So let me go back and fix the first one. Oh, and I forgot my closey brace. Okay. All right, so now the shell is going to see I've given it something in double quotes, so it knows not to try to glob this thing there. The question mark is not a glob character, and the star is not a glob character because it's in double quotes. But this thing here, the $, it knows that's a variable substitution, so it's going to go ahead and replace that variable with the 6. So now when I run it, there is my output line. And I'll pipe that guy into SHASUM. And we already saw that it starts 48E. Yeah, there it is. Does anybody have any other questions about the quiz? So I gave 2 solutions to this one in the feedback for the quiz. One does it this way, where it uses tr and word count-l. Another one puts it into a while loop, where it increments a counter where the number keeps going up until it doesn't find a match. So it finds lines that have 1 question mark, it finds lines that have 2 and 3 and 4 and 5 and 6. Then when it tries 7, there is no match, and grep returns failure for when it tries to find 7. And that's how it knows to stop, and that the answer was 6. Nobody has other questions about the quiz? Isn't it going to be expensive? Running it through a loop? Yeah, because it has to go through it 7 times. Whereas this solution, well, it reads every file twice. In this case, it was okay because it was small enough. And I figured you guys would be more likely to try the looping solution rather than the TRWCL solution. So I provided it in case you attempted it. Actually, in the looping solution, I ran it with -q, which I'm pretty sure will stop once it finds the first match. So it won't be super expensive because it's going to find a line that has 1 question mark on it pretty quickly. It might take longer to find the ones that have 4 and 5. So yeah, it's more expensive than it needs to be. This one only reads the files twice, whereas the other one reads all of the files however many times it needs to search for question marks, so 7 times. So does anyone have other questions about the quiz? Which one are you talking about? The TRDC or the one with the loop? So it will go through the loop 7 times. I'm fairly certain, I haven't checked, but if you run grep with -q, you tell it to not display any output. So if it runs with -q, it should be smart enough to stop once it finds the first match, because the only question posed to it with -q is there a match or not? Haven't verified that that's the way it actually behaves, but that's the way I would have made it behave. So when you ask it to find, is there a line that contains one question mark, it should theoretically stop after it finds the first match. Or maybe it doesn't. Maybe it consumes the entire input. I could see it going either way, actually. Okay, so no one else is typing anything. So I assume that means no one has a specific question about the quiz. And we're out of time anyways, it's 4:30. So I'll post something about office hours over Discord. And if you don't have Discord, it's easy to get. You download and install it and it'll be fine. And I guess I'll post a link to a server there. And I can either talk to you through voice chat on Discord, or we can just type in a channel and it'll be okay. Right, so I'll do that. Please do the quiz. I'll post an assignment as well, and I'll have to look at the calendar for Langara to see when it's going to be due. And I'll also contact your marker to figure out what's going on with the old assignments, because I expected at least one of them to be back by now, if not two. All right, so I'm going to end the stream here. Thanks for listening, and maybe I'll talk to you tomorrow in office hours, and if not, I hope we have class next week. I haven't actually looked at a calendar, so we'll figure it out. So see you guys later.